Hi, I'm Will Cohen, and I am a performance tools engineer, and I work in the tools group at Red Hat. Today I'm going to talk about some of the cool features in Fedora 14 that are in GDB. If you're a Python programmer, you actually may be interested to know that GDB now allows you to write scripts in Python. And the advantage of this is that now you can do some very advanced analysis in GDB. Okay, and now we'll do a short demo using GDB heap. So what I do is I'm just going to start up GDB heap on CC1, which is the program that converts the C code into assembly language. Now what I need to do is I'm going to load some breakpoints. I already have them in a file, breakpoints.txt, and so now I have a breakpoint in main, I have a breakpoint in the start of initialize plugins, and I have a breakpoint in exit. So I have those three breakpoints. And what I need to do now is I need to import the Python heap tool with Python import heap. So that's all ready to go now. So what I'm going to do is I'm just going to run it on a very simple hello world program. And this has already been pre-processed, so that's why it has an I at the end. So I run that, and it stops in top level main. I can now take a look at, there's nothing on the heap if I type in just heap. If I want to see what commands are available in heap, I can just do heap and then hit tab. And that shows me the various commands I have available. And we'll use a couple of these in just a moment here. So now what we'll do is we'll continue to the next breakpoint. And we now can take a look with the heap command and see what's been allocated. And we actually see now that things have been allocated. And we can see that the total amount of memory taken up is 187 kilobytes in the lower right-hand corner. And we see there are a total of 997 allocations. Now, one of the really cool things you can do with GDB heap is you can actually store that information about what's been allocated right now. So we can do heap label init plugins entry. Okay, so we now have essentially a checkpoint saying at this point I had these allocations, and what we can do is we can we'll allow the program to finish the function. So now we're at the end of that function. We can take a look and see if if what's been allocated, and we can see that it's still the same as before. We could do a heap diff to get a list, and we can see that the heap diff shows that we have no additional bytes and no additional blocks allocated. So what we can do is we can continue to the next breakpoint, which is going to be in that exit. And we can see that it's printed out saying, it took me this long to do this. And we can do a heap command to get a list of what was allocated. And we can see at the very top there, we have 3 blocks rather than 2 blocks that were allocated at 32 kilobytes each. And we can see the total is now 378K. And so if we now do that heap diff, we will actually see that there were additional blocks that were allocated between that time that we did initialization in the plugins and now. So we see in this case we have 190K of bytes that have been allocated initially, and then we also have 983 blocks, and those bytes are in 983 blocks. So you can see the work done by Dave Malcolm on GDB heap. You can see the work done by Tom Tromey on GDB index in Fedora 14. And next time you have a program that used too much memory in Fedora 14, maybe you can consider using GDB heap to debug and find out why it's using up so much memory.